Hello, back again. So yesterday we went over arithmetic sequences to find the recursive model and the explicit model. Today we're going to go into geometric, which means we're on page 2. We're going to look at our vocabulary first to see if there's things in here that you're going to notice that we have that we're going to be covering today. So common ratio, geometric sequence, multiplicative, recursion, recursive rule, a relationship, and subsequent rows and tabular. So kind of the same things as yesterday for the most part. And now I went ahead again and set up the table. I'm just pinch this out so I can do here. Took it horizontal and made it vertical, and we're going to go ahead and come on down here and look at that recursive rule. Again, we're looking for a sub 1 and a sub n, which is going to be something with an n minus 1 with our recursive rule. Alright, so come on over here and grab a nice pretty blue. Okay, so if I just get this table, and by the way, I realized that yesterday I should have labeled my input as n and my output as a sub n. So just remember, we'll fix that in the tables when we get ready to do that. So n is our step number, and a sub n is our step, our result of that. Okay, so if I try to do a common difference, I can already see here, if I take 4 minus 2, that would be a plus 0.02, and from 0.4 to 0.8, I get 0.04. Sorry, my lines are showing up here, and this is going to be 0.08, and this is going to be a difference of plus 0.16 and 0.32. So if you notice something really interesting, and this is again a pattern. If you notice that there's a pattern that your outputs, when you shift it over, are exactly the same when you from just drop down one row, and they're not all coming out like plus 4 plus 4 plus 4. It is not a common difference. You can stop after you do like the 1 or 2 or 3 of them, because this is clearly growing. So what I'm going to do is I'm going to come back and I'm going to erase all of those. And if that pattern shows up, it tells me as a mathematician that I don't have a common difference. I don't care how many times I do that, I'm never going to get a common difference. Not if I try a second common difference, which we'll find out what that means tomorrow, and a third common difference, which we'll find out the day after. So instead, if I'm not getting the same values out using subtraction to find out what's going on with my subsequent rows, I'm going to do what's called a common ratio, which means I'm going to take my second value and I'm going to divide it by my first value. So if I take 0.04 and I divide by 0.02, I get 2. And if I take 0.08 and I divide by 0.04, I get 2. And if I take 6, and if you think about this, I know sometimes people have problems with decimals, but if I think 16 divided by 8 gives me 2, 32 divided by 16 gives me 2, 64 divided by 32 gives me 2, 10.24 divided by 5.12 is going to be 2. So we have a common ratio. You can use a calculator. Let's see if I can get in here. I don't think I have Desmos loaded on here, do I? Actually, I could just go out to Desmos. Desmos is going to be a calculator that we use quite a bit. Just want to look at the calculator though. And if I just take those numbers and I divide them, come on, give me my keyboard here. I want to take 0.04. Back up. 0.04, and I divide it by 0.02. I need a 0.2 in there. Okay, I get now 2. If I take 0.08 and I divide it by 0.04, I get 2. And if I take 0.16 and divide by 0.08, I get 2. So that's what I'm getting. I'm getting that common difference of 2, that common ratio of 2. That tells me that it is exponential. All right, so back over to this. So what? Okay, remember that we want our recursive rule, which is a sub 1, which is 0.2. And then we're going to take, again, with our recursive rule, they've got 2 times a sub n minus 1. So what they did is they took, and they multiplied it by 2 to get 0.04. And then took a 0.04 and multiplied it by 2 to get 0.08. Now remember 0.04, this is a sub 1, this is a sub 2, this would be a sub 2, times 2 gives me a sub 0.08, which would be 3 over here. Now let's see if I can get it to move. It's not letting me move right there. Use my mouse over here. So 3 is 0.08. Our explicit rule for this is that to get, let's do this in, I don't think you should call it, took a sub 1, which was 0.02, and we multiplied it by 2 to get a sub 2, times 2 to get a sub 3, times 2 to get a sub 4. So if I am looking for this, this is an exponential function, and exponential functions are whatever we are repeating by, that is going to be our base. So we're going to have, for our explicit rule, just like in our other one, we need to find out what a sub 0 was. So if I take my base here, which is going to be my base, we're going to need a sub 0 and our common ratio. So we're going to take that a sub 1 and we're going to divide it by 2, which is going to give me 0.01, and then our base is 2. So our a sub n is going to be equal to a sub 0 times our common ratio. So I'm going to do CR here, common ratio, parentheses. And then when you have repeated multiplication is going to be our n. So let's see if this works. We're going to have equals 0.01 times 2 raised to the nth power. Well, let's see if that works for 1, and let's try 6, 1 and 6. So if I do a sub 1 equals 0.01 times 2 raised to the first power, I get 0.01, 2 raised to the first power, of course, is 2, which gives me 0.02, which is what we have over here, right? And this is 6 1. There we go, 0.02, okay? And, come on, be nice. Let's do a point here. A subscript 6 equals 0.01 times 2 raised to the 6th power. All right, we can use our calculator, but we're not going to use our calculator, so we're going to do times 2 times 2 times 2 times 2, 4, 4, 4. 4 times 4 is 16 times 4. So we're going to start learning a little method here. 10, 6, 4. So 10 times 4 is 40, and 6 times 4 is 24. Add those two together, we get 64. So we should have a to the 6th times 0.01 times 64 is what we're going to end up with. It's going to be 64 cents. Sliding up and over. There we go. A sub 6 is 0.64. And that's all we have for today.